Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of multiplying polynomials. This is standard A.10B in the great state of Texas, and we are using item number 16 off the Redesign Practice Online STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we need to find an equivalent expression to these two polynomials being multiplied by each other. And let's just define what I keep referring to, right? So we've got polynomials. Those are expressions that include many different terms. So we've got constants, right? So that's going to be your 5, your 6. We've got variables, right? So I've got a z. And then also sometimes you get exponents. So this z squared is actually kind of different. We're going to treat that differently because you've got that z squared. This one right here is actually called a binomial. That prefix bi meaning 2. So I've got 2 terms. And this one right here is actually called a trinomial because it's got 3. Tri meaning 3. All right, so how do we multiply these things? Well, all of this kind of comes underneath the distributive property. And so let's make sure we kind of get our basis in that. So if I say A times B plus C, I could distribute out that A to both the B and the C, AB plus AC. We can't use FOIL for this. FOIL is our first, outer, inner, last, because that works with 2 binomials. But since we've got that trinomial, there's 2 different inners and things get a little bit weird. So what we're going to do is we're going to distribute this. We're going to take this Z, right? And I'm going to take that Z and I'm going to multiply that by each of this whole thing, right? Z squared minus 4z plus 6. Then I'm going to take that plus 5 and I'm going to multiply that by z squared minus 4z plus 6. So I distributed out the z plus 5 to both of those. Now I need to do the distributive property again, right? So z times z squared. And then I've got this plus z minus 4z plus z and then 6, right? Then I need to go and do that same thing. I've got a plus 5 times each of these z squared. And then I've got a plus 5 minus 4z. And then a plus 5 and then plus 6. Now, I can multiply all of those. I will be looking for like terms. So I've got z cubed, right? I've got a minus, since I've got that minus 4, z squared. I've got a plus 6z. I've got a plus 5z squared. So I'm going to combine that z squared and that z squared. I've got a minus 20z. So now I'm going to combine that one and that one. Then I've got a plus 30. So combining like terms, I've got z cubed. I'm going to combine those z squared because I want them in descending order. Minus 4z plus 5z. So that's really just a plus z squared. Now I've got a z. So minus 20 plus 6 is going to be a minus 14z. And then I've got a plus 30 just sitting at the end. So we see this here, and we're looking pretty good at C. Now, there is another method we could use, the box method, right? So what we could do is we can take your z plus 5, we can take your z squared minus 4z, and then you could take your plus 6, and you can kind of set it up like this and multiply each of these terms by each other in each of those boxes. You'd end up getting the same answer if you multiplied like that, be your z cubed, 4z squared, 6z, 5z squared, 20z, and then 30, and just add your like terms, boom, and then boom. But either way, we're going to get our same answer here of C.